Hello, this is Math 140, day 7. I want to do a problem about distance, rate, and time. I would rather call it distance, speed, and time, just because Alex calls that rate. Rate can be anything divided by something else, but if you're talking about the distance over time, I would usually call that speed. And that's his word problems, obviously. So here's a word problem. So Reina, I don't know where Alex comes up with these names. Drives from Ames to Kansas City. And she takes 6 hours because there's heavy traffic. And then she drives back and makes it in 4 hours. So let's say the next week she drives back. Because she's lucky and there's no traffic. Suppose that her speed was 22 miles per hour faster. Faster than the first trip. What is the distance of Ames from Kansas City? Okay, first thing is a lot of words, and the biggest deal is probably to rephrase that, extract the information and condense it to just a few math equations. And to do that, the first thing should be give names to relevant quantities. Name relevant quantities. So I would suggest give that distance a name between Ames and Kansas City, because it's what they're asking about and it's unknown, so that's definitely something to deserve a name. What else is unknown? V1 is the speed on the first trip. We're talking average speeds here. And V2, average speed on the second trip. They're obviously all unknown, but we have clues about them. And going through that problem in order, the trip out took 6 hours. That means D is 6 times V1. It's always distance is time multiplied by velocity. Distance traveled is the time it took multiplied by the speed and velocity is a fancy name, so that's why I call these things v. On the other hand, on the way back, it just took 4 hours, so 4 times v2. It's the same distance going out as coming back, obviously. And the other clue that we have is the speed on the second trip is 22 miles faster than on the first, like this. Make sure you add the 22 on the right, so it means that V2 is bigger than V1. That's a quick check. Yes, that's what we need. Okay. So we got 2 equations with 2 unknowns. If you just forget about that D here, that's really just 2 equal signs that we're looking at with 2 unknowns. And that's something that we can solve either with substitution or with the method I showed you in the last class period. And here it's just an obvious thing that we can do substitution. We can write 6v1 is equal to 4 times, and replace that v2 by v1 plus 22. Then you're down to 1 equation with 1 unknown, and we got a good feeling about this, right? So expand this out. This is 4v1 plus 88. We want to subtract 4v1 from both sides, so like this. The vertical bar means this is something which you need to do to both sides of the equation. So it'll just leave me with 2v1. That 4v1 is gone, and it's 88, all that's left. So we divide by 2, and the v1 is 44. Are we done? No, because it asked about what's the total distance. And that was 6 times v1, so 6 times 44, which is 240 and 24. And that is 264. Our unit for distance is miles. At that point, I remember the unit and put that back in. Of course, I just checked it's vaguely realistic. I'm not claiming it's the exact distance, but that's what the math comes out to be, okay? Why is it miles, not kilometer? Because we measured the time in hours and the speed in miles per hour. So if you had put those units in, you would have seen that really the miles survive, and that's the unit for distance compatible with the miles per hour and the hours. So, not too bad, I think. Those problems, when there's 2 cars, like in my last example, that would be complicated enough to make a little sketch to see whether you are 2 moving objects approach each other or go away from each other, whether you need to add or subtract stuff. But here, I could get by, and I think that's enough for this example. So see you tomorrow in class.